Introduction to higher order linear differential equations. The order of a differential equation is the highest derivative that appears in the equation. So for example here, second order is, one example of a second order is this one. As you can see, the highest derivative that you see over here is two derivatives for y right here, right? Now this next equation here has fifth derivative for y, therefore the order of this differential equation is 5. Now when we say higher order differential equations, we mean equations whose order is 2 or above. And these are much harder to solve than first order differential equations. Therefore we are going to take a different approach than what we have done for first order differential equations. Now let me explain by an example that you may have seen in your grade school. So let's say you're given this equation 3x minus 6 equal to 0. Now there are two ways to go about solving this. One is to solve it honestly. So you add 6 both sides to get 3x equal to 6, and then divide by 3 to get x equals to 2 as the answer. But some students might just look at this and say, let me just guess. If x is 1, 3 minus 6 is negative 3, it doesn't work. If x is 2, then 2 times 3 minus 6, hey, that works. So x equals to 2 is the answer. Now, all your life, you're probably told that guessing is bad and you should learn how to solve equations. However, when it comes to higher order differential equations, we will actually be guessing rather than solving. Now, to make it sound a little nicer, we will do educated guessing, and much of the learning would be invested in what type of solution should be appropriate for our solution. We also call it solving, so we can feel better about ourselves. Okay, but really, what's going on after second order and afterwards are just educated guessing. Now you might wonder, what justifies this guessing? Well, thankfully, guessing the solutions of a linear differential equation is justified because mathematicians proved two important theorems about it. They are first, existence of solutions, and then uniqueness of the solution given appropriate initial conditions. Existence allows you to go ahead and hunt for a solution. If we don't know whether a solution of a differential equation exists, then we may end up hunting for the solution forever without finding it. Or we might have a wrong idea of solution and wrongly think that a solution looking thing that we have in front of us is actually a solution when it's not, right? Now, uniqueness allows you to say that the solution you found is the only one, and thus you don't have to find any more, okay? So with these two theorems by mathematicians, we lay people, well, I'm a mathematician, but lay people who just have to use the theory of differential equation, they just can go about actually guessing solutions and then use it as the answer. Now, we need to delve into this uniqueness business furthermore. Now, I talked about something about the initial condition. So here is more explicit statement. For second order linear differential equations, there is only one solution if you set values for ya and y prime of a for some value a. So for example, if you have the second order differential equation with y of 3 equals to negative 1 and y prime of 3 equal to 4, then you have only one function, y satisfying this differential equation. And this here, this y of 3 equal to negative 1 and y prime of 3 equal to 4 is called an initial condition. For nth order linear differential equations, n initial conditions should be provided to have a unique solution. So, for example, if you are working with a third order differential equation, then you would expect to have only one solution when 3 initial conditions are provided at a point. So say y of 0, y prime of 0, y double prime of 0, if those three are supplied for a third order differential equation, then you know that equation has only one single solution. Now recall that when you solved a first order differential equation without an initial condition, there was always a free parameter c in your solution, right? And that c was only determined after you were provided an initial condition. Same goes for second order. Second order differential equations without a given initial condition will have two free parameters, because only after providing two initial conditions you can set those, or you can determine those two free parameters. So third order will have three free parameters, fourth order will have 4 free parameters, and so on and so on. That's what uniqueness theorem means.